Thank you for joining, everyone. So I'm the program manager for scientific computing in the hub, and that means I coordinate the compute platform, the ELIXIR compute platform. And I am ably assisted in this with Gavin Farrell, who's also on today's call. So he's the technical core. Hi, Gavin. And as people will know that are directly involved, it's very much a joint team effort. So Gavin's helped compile some of the content for these slides. And what I've tried to do is give a comprehensive overview of the ELIXIR compute platform, where it sits in our technical program in ELIXIR, and the kind of work it does, the engagements we have across ELIXIR and our communities and projects and so on. And then finally, a forward look at what we have planned, what we are planning towards for the new ELIXIR program. And the usual kind of helpful links to get involved. So there is quite a bit of content. Partly this is just so that you have it here in the deck for reference, sort of one place that people can access links for many of these, many of the more detailed information that sort of feeds into all of this that I'll talk about. So first of all, I'm aware that not everyone here will be familiar with the detail of ELIXIR itself. So I'll just very briefly recap the where compute fits into the sort of technical infrastructure of ELIXIR and how we organize that through our hub. But only very briefly. I'll refer you to the previous webinar in the series, or one of the first webinar in this current series, which was led by Peter McCullum, our CTO. So he described an overview of ELIXIR itself and how the technical team and the platforms fit into that. I'm then going to talk about why we need a compute platform, look at some of the detailed areas that we work in. There's three sort of broad areas in particular. And then, as I say, start to talk about some of the engagements we have and how to get involved. So do please make any comments that you wish to in the chat as we go along. I think we'll try and finish leaving plenty of time for some questions and answers, and we can check in on Slido. So the platforms themselves, those fit in. There are sort of 5 technical platforms. That's the smaller circle in the middle of this diagram here. Compute is one of 5 alongside the tools platform, which I also coordinate with Manthos assisting, who's on the call. And then there's the data, the interoperability, and the training platforms. And all of those connect as much as we can with our many now a growing number of communities in ELIXIR, which you can see in the outer circle here. And so everything we try to do is because our communities need it, and we can hopefully, by working in a coordinated way across the ELIXIR member states and with our global collaborators, we can hopefully address these difficult problems. Okay. So the technical team itself, some of this material will have been covered in the first one, but this is where we fit in. So I've introduced Gavin earlier. He and I are both underlined here. You'll see I'm one of 3 program managers alongside Fabio and Katharina, and we together coordinate across these 5 platforms and across the communities. In my case, I also take a lead in ELIXIR on coordination of our activities in the European Open Science Cloud. That's one of the topics we'll come back to. David's on hosting the call today as one of our technical support officers, and Gavin works in particular on compute, but also across a very different platform, the data platform. And you'll see we have this sort of nice matrix way of working so that we can share learning and knowledge across these platforms. So specifically, we act as an interface between our nodes around across ELIXIR, mainly in Europe, and the international activities and the coordination of those. We're co-located with one of our nodes, EBI, European Bioinformatics Institute, on the Wellcome Genome campus just outside Cambridge in the UK. compute platform, the story so far? Well, researchers need access to data that they can analyze in a reliable and reproducible way. Trouble is, data not located all in one place. At least some of the data is sensitive and needs special protection in the life sciences in particular. The analysis is complex, requires workflows that support individual steps, and data and service capacity providers need to properly control access, and that may include guaranteed identity vetting. And when you learn more about the kind of projects that ELIXIR is involved in human data in particular, you can understand why. So to be able to achieve this goal, we also need strong digital identity vetting, and that has to be relatively easy to use for researchers, but trusted by providers. We need trusted, secure environments that retain an audit of those sensitive processing steps, and technologies that support reproducible processing. And that also means flexible environments supporting a wide range of distributed services and data sources. And what we're trying to provide is a powerful, secure, federated processing infrastructure. Not everyone has that powerful compute environment in their local institution. So the compute platform itself was first established in 2015, and it's broadly organized its work around these 4 areas. To build and integrate across cloud computing, the compute processing itself, the storage and transfer of data, and importantly, the access services for the life science research community. In terms of the leadership of the platform, then I've already introduced myself and Gavin in the hub, but then we have 3 key individuals who are members of the executive committee for the platform, drawn from 3 of our nodes, and those slowly change over time, over a sort of 2-3 year timescale. Since the beginning, we've had Ludek Matejska from the Czech node, and more recently joining are Juha Tornroos from Finland and Harald Wagner from the German node. So they co-lead on behalf of the nodes, the activities and the direction of the platform. And so the coordination, as I say, major areas of technical and scientific strategy overseen by the program managers, including myself in this instance. That means development of technical roadmaps, leadership roles in project activities, and guiding the platform and community leadership teams. And then we have this team of technical and science officers in our hub technical team, and they directly support some of the logistics around the platforms and the communities, participation in projects, some of the operational processes, and managing data from our nodes and services, as well as outreach. So coming back to the 3 expert leads, they're this so-called executive committee. So I've mostly said this already, but the platform, like all of the platforms, does draw its membership from across the nodes, and we collaborate globally. The working structure was set in 5-year programs. So we're currently into the last year of the 2019 to 2023 ELIXIR scientific program. And that document you'll be able to find through the link in the slides here. That covers the strategic plan, the ambitions for ELIXIR, and then more of the detail of the platforms themselves and what they hope to achieve, along with all the other aspects of what ELIXIR does. And tasks are our current nomenclature for platform coordinated activities. So these do change over time. So there's a 5-year program from 2019 to 2023. Those were revised somewhat for this final 2 years of the program for 2022 and 23. And the current 3 task areas are as listed there, and I'll be saying much more about those in a minute or 2. Something I'll highlight here, but won't say much more about today, is a joint compute and tools platform strategic implementation study. So this involves sort of anywhere at different times over this period, 13 to 17 of the nodes in ELIXIR, working together, identifying use cases, and trying to bring together all of the different aspects from the tools platform, the biocontainers and so on, and then how to run and execute those across compute environments. So that will be a future webinar in itself that we'll do at the conclusion of the current study in the summer of this year. So the first task is so-called AAI, or Authentication and Authorization Infrastructure. In overview, this has been co-led for many years by the Finnish and Czech nodes. Mikael Linden actually recently left after many, many years of thought leadership in this area. But he and the team in Finland have always worked closely with the Czech node in particular in this task. So those two nodes have really led the development of this work over many years, as you'll see. Those wanting more detail of the nitty-gritty, there's links to a task. After Mikael's departure from Finland, Mika Tuisku is currently co-leading on behalf of Finland there. So what is AAI? As I say, authentication and authorization infrastructure. So this is how you sign in to a whole range of services using your home identity, your home organization account, for example. Now, it can either be a university or institute account, and that therefore enables you potentially to use those university attributes to get elevated access to particular data sets, for example, subject to all those things being in place, of course. But the ELIXIR AAI, what's now becoming known better, and I'll talk about this in a minute, the Life Science Login Service, which is an AAI service across the European life science infrastructures. This is a way of accessing data sets using one home identity. So instead of having to pull out your bunch of keys, access one service in your processing loop with one key, find another key from the bunch in order to get into the next resource, could be compute, could be a tool, could be a data set. What we're doing here is bringing together the life science services so that they can use one common identity. You can use a public identity, a Google, Apple, LinkedIn type identity, but of course that would only give you public access to publicly available resources. So a classic example here is accessing genomic data through your AAI service via the federated EGA in Norway, for example. So the platform itself focuses on the community engagement, because this is work that has built up over many years, and so we're still spreading the word. Training, both for users, but also importantly for providers, so service providers, how can they make their service work with Life Science Login? And the integration of those services, so that relying service integration. And I've just included this slide quickly because just to spread the message really that building this kind of detailed technical infrastructure does take time. So there's a long 10-year process from the beginnings in autumn 2014, very beginnings of ELIXIR, gathering use cases, the requirements and the design, working through major projects, European projects such as Accelerate, Corbel, and the ARC projects. Those were incorporated under the compute platform, and the initial service entered production in November 16. But then increasingly that was developed into ELIXIR's first infrastructure service from 2019 onwards, and that's operated by the Czech node, working closely with Finland. So Life Science AAI, which I'll come on to talk about in a minute, entered production building on ELIXIR AAI in 2022. All of our users were migrated during 2022, in fact, early 23. And then we're now in the process of slowly onboarding relying services. But those services which haven't yet onboarded, they can still be used. They are still compatible with ELIXIR AAI. So the operations is a complicated service. It's the maintenance of all those servers and services, ensuring information security, integration of new features, supporting communities who want to use it for their services, and registering and supporting those services. And as I say, operated on behalf of ELIXIR now by the ELIXIR check node. So that means first and second line help desks and so on. The AAI implementation study focused on this, provided a sustainable service, and in particular prepared for the migration of this service into a broader life science-wide AAI service, this so-called Life Science AAI. And that work was carried out through the EOS Life project in a dedicated work package. However, as we come to the end, the final year of the current ELIXIR program, we are still providing a sustainable ELIXIR AAI service now and managing those migrations of services. And that also means operating ELIXIR specific components, which not yet compatible with the wider life science AAI, but are of particular use in some of our ELIXIR services and communities. So those things will gradually be ported as needed into life science AAI. And importantly, we still have ELIXIR AAI as a kind of test environment for developing prototypes of new services. So EOS Life, I've mentioned a few times now. This is the 13 partner research infrastructures in the life sciences, so-called cluster, science cluster. You'll see many of the logos there. It includes biobanking, BBMRI, ECRIN, EARTRIS, so, clinical trials, all sorts of different areas, Eurobioimaging, Instruct for structural biology, and so on. And in particular, Compute Platform has worked together with European-wide partners across ELIXIR, but also across these other partners in the areas of AAI and the development of this life science login, and the cloud work, which I'll come on to again later. And so the motivation for this was that it's not just across ELIXIR, but across this much broader set of life science infrastructures and services where we would like to have and deploy a common identity. So ELIXIR and our leads in ELIXIR have been part of this journey for many years now through various projects to build a common blueprint, essentially, for services operating in this way. And that those are therefore compatible across EOSC, the European Open Science Cloud, across all the different domains in time. So each cluster, each domain within the European Open Science Cloud, being able to run its own service, but running them according to common internet standards so that you can use a common framework across those services. And so this is really just summarizing that migration process, that all the users migrated by 2022, end of 22, and that the relying party migration is the ongoing work now. So increasingly, we just refer to life science login, where we used to refer more specifically to ELIXIR AAI and ELIXIR login. And an important footnote, but something that takes a lot of time and took a lot of dedicated effort across the partners during EOS Life, is developing all of those appropriate policies to make this possible. So how do you work across these different international compute environments? And that means for users, for identity providers, e-infrastructures, the data processing agreements, and so on, and the various common policies, what happens if, etc. So that's been a very important part of what we've done, and you'll see there's still more to do. So I've mentioned this already in a few words, but we need to fit in the Life Science AAI into this broader federation of European Open Science Cloud, or EOSC, services, so that they follow a common blueprint. And so ELIXIR has been a leading member of developing that method of work. To give you an idea of numbers, we're talking here about thousands of logins per month, many thousands of users. And you can see, as we've made that migration into a life science wide AAI service, gradually the numbers are going up significantly. It will take time to onboard more of the other research infrastructure partners in the life sciences, but we already have, just through just during the last year, a near doubling of the numbers of users. And as you can see, hundreds of groups involved in that. When you have access to the slides, you'll be able to dig in much deeper to the various statistics and services if you're interested. And I've also included here a whole set of the links that I've referred to, and the blueprint documents and so on. Importantly, none of this happens without that community engagement. And so a major part of the AAI tasks in ELIXIR is that community engagement. So various online sessions, recordings available for all of them and deposited through the ELIXIR tests training database. So let's move on to the second task, hybrid cloud. This has been co-led, or currently is co-led by the Czech, German, and EMBL EBI nodes, and you'll see the names of the individuals leading there. The link again in the slides to the more detailed outcomes and plans and proposals. What do we mean by hybrid cloud? Well, here's one definition. Actually, this was supplied by Santiago Insua in EBI, who's one of our co-leads here. So he uses or adapted a Red Hat definition that hybrid cloud is an IT architecture that incorporates some degree of workload portability, orchestration, and management across two or more environments. So depending on who you ask, those environments may include at least one private cloud and one public cloud, two or more private clouds, two or more public clouds, a bare metal or virtual environment connected to at least one cloud, public or private. It's messy. The focus of the work, it's still very much an area that's undergoing rapid development, is demonstrator pilots. So where we need those for some of our federated projects and demonstrators. And then really building a publication, the sort of state of the art across ELIXIR now. Here's some examples of this kind of approach, computing approach in practice. So why hybrid cloud in bioinformatics? It's about extending access to compute resources that are not available or not many of them on premise. And that might include if you need graphical processors. It's about being able to burst temporary peaks of load due to project or workload requirements. We saw that in action during the pandemic response. Abstraction of different infrastructures and the reproducibility of those, and access to advanced tools for machine learning and artificial intelligence applications. And then when you start to get, I won't get too much more detail than this, but you start to get into the nitty-gritty. We're talking here about potentially Nextflow workflow manager executors. So that's a component that determines the system where a pipeline process is run and supervises its execution. And currently Nextflow supports different executors for commercial public clouds and more in general for sort of high performance computing for the scheduling and Kubernetes. So a sort of example hybrid cloud diagram being that's used and relevant in EMBL EBI, for example, is that sort of classic load and transform processors that typically are just using local storage, and you may use Slurm workload manager for that. And that then when it comes to the analysis and the visualization, you start to need wider federated resources for federated users and use of public cloud. And that can be potentially managed using Nextflow and with reference to container registries, GitHub, and so on. So during the EOS Life project through Work Package 7, that was where the effort across Europe was focused in life sciences on cloud provision in support of scientific projects. One of the key outcomes from that was that the expected demand was actually undersubscribed. And when you dig deeper, what we found was that what this really reflects is the technical barriers to adoption and the shortfall of relevant expertise in the research groups. And this really was brought home to us during the pandemic response, where our ELIXIR experts in this area were really the sort of bottleneck in terms of people being able to use computing resources across Europe that were made much more easily available than normal. You could, all sorts of policies were relaxed during the pandemic in order to let research groups work as quickly as possible on an important analysis. But the real bottleneck was that many of these expert research groups don't necessarily have that technical expertise either in-house or even easily accessible in their institution. We know there's a real shortage of that. So an important outcome of the EOS Life work, and where ELIXIR was a major contributor, led by EBI, was onboarding training onto technical cloud resources. Denby Cloud in Germany is another good example of where they've provided a lot of training courses for research groups who want to use this kind of resource, and also just knowing when and if they need this kind of more advanced computing resource. All of this work is summarized in this publication I've linked here, so-called EOS Life Final EOS Life Science Cloud Observatory Report. So we're continuing to work towards defining what we mean by the ELIXIR Hybrid Cloud. And that's really when you start to talk about hybrid versus multi-cloud architectures. And multi-cloud is becoming more of a focus here, as really hybrid is just becoming is implicit really in all of these in most of these scenarios. So the use cases are potentially difficult to collect. It's about identifying where the need really is, as well as where there are some examples in practice. It's a lot to do with resourcing and the difficulties of paying across national boundaries for compute resources for distributed use. But there are flagship demonstrators. I've given a couple of examples here. I'll come on to in task 3 some of the workflow and task execution examples that we're working on in the platform. Let's do that now. So container orchestration is the third and final theme of all of our current work. And that's been co-led by a wider number of nodes. This was an evolution that happened during the 2019 to 23 program. More of our node effort and expertise was focused in this task than had been the case previously. And you'll see there's 6 different nodes involved in co-leading this activity. And it's been organized for many years now by utilizing the standards in cloud and identity management as developed by the Global Alliance for Genomics and Health. Now, we could give a whole talk about the different ways that ELIXIR interacts and co-develops standards in the GA4GH, but I'll just reference it briefly here, that's a kind of framework that we've been using to develop the standards for cloud computing in this area. And so in container orchestration in particular, it's about coordinating the ELIXIR services for executing containerized software workflows. And those might be developed and managed by members of the tools platform, compute platform ecosystem, and so on. So that really feeds into that joint implementation study I mentioned. And of course, the user engagement and support. So under this task, we have led the representation in Global Alliance in the cloud work stream. So this is working closely with NIH and others internationally, NIH in the US, of course, and various partners who focused on genomics here in particular, but where there's a shared interest in developing solutions of this type. And so we've prototyped real-world use cases. What you'll see as I go into the final part of the talk in a few minutes is that this is where we're really starting to move from proof of concept to real deployments through some of the major projects we're now coordinating or engaged in ELIXIR. So this is a technical area, and I'll keep it brief for now, but signpost the way to more of the detail of what's involved here. So the federated cloud environments for data analytics based on those standards, as I said, and we have this long established driver project in the Global Alliance around the standards developed for cloud and AI. And this is about public deployment for end users, as well as the sort of software development kit for cloud adoption that's of most use to administrators and developers. And it's all built on a microservice architecture suitable for on-premise, hybrid, and multi-cloud use cases. And there's a whole range of standards that are involved. These are the key ones. So our AAI work, we were the co-leaders of this passport standard in the Global Alliance. At the time, that was co-led with Google, but involves many others too. Then there's the 4 cloud execution standards. So this is tool registry service APIs, data repository services, workflow execution, and then in particular, ELIXIR has really pioneered the task execution service APIs. And those are very important for real world applications. ELIXIR is enabling the federated analytics through the use of these federated specifications. And this is all about this trend we see now in recent years, that to send the compute to where the data is rather than somehow porting the data to a specialized compute environment only. And a nice demonstrator now a couple of years ago was using the public GWAS 1,000 genomes data. Through Global Alliance, we were able to demonstrate integrated use of all of those cloud standards, not yet with AAI actually, although that integration is now possible and is being worked on. But we were able to demonstrate the use of all 4 standards in this 3rd column here, and we were able to deploy that simultaneously in 5 of the different ELIXIR nodes involved. And so that was a really nice example of global collaboration, collaborating with 7 Bridges, Terra, DNA Stack in that particular demonstrator. And here's an even bigger set of collaborators that have worked with us, are still working with us, that we need to work with in order to make all these things work. There's probably a much longer list than that. There's a very active collaboration at the moment with Microsoft research on that TES task execution standard, for example. And then I won't read through this now, but here's a list for all the more detailed, the GitHub repositories and so on, for those interested to dig in deeper. And final reference to, here's what, just in one slide, here's what the container deployment study has worked on. This is this joint initiative with the tools platform and a whole load of work to coordinate what a container deployment service might look like, and we hope in the new program to take that towards real deployable services. So let's look at a couple of examples in the nodes. I've just picked one here in the interest of time, the Denby Cloud Federation in the German node. So this is a fully academic cloud federation established since 2016, free of charge for academic use. And the federation is maintained through these distributed cloud centers located in the centers shown. And so here's a sort of example of the kind of scientific cloud and the power of the compute available to researchers. It is fully integrated with life science login. So a PI at a German university or research institution can apply for cloud resources, and they can then use the life science login to log into that service and get allocated resource on a cloud site. You can see here, since the beginning of that cloud federation, the large growth in the number of projects and the number of users, registered users, making use of resources. And then lastly, here's an idea of the kind of associated citations using these multiple resources. This does include, of course, in the German node, a large number of use cases from Use Galaxy. So finally, some examples, or not quite finally, but some examples of wider engagement. I've actually mentioned this, so I'll just skip over this now, but this is an example, the COVID-19 response. You'll see a long list here of compute resources across our nodes that were made available at short notice for all sorts of urgent research activity during the pandemic. We engage, of course, in individual communities. Just picked out a couple of examples here in single cell omics. Federated human data community is, of course, a broad church, and in particular, some of us were just attending the genomics data infrastructure initial meetings, the technical pillar work, where all of the features that I've described that the compute platform has been working on are strongly represented. In other words, we expect to deliver this major new European project on and building a genomic data infrastructure founded on exactly the sorts of services and the work that I've described that have been coordinated in recent years by the compute platform. We, of course, are very mindful of wider initiatives, including the EuroHPC, so that's high performance computing joint undertaking. The key point here is that 2 of our nodes are computing centers, so are 2 of the 5 initial set of EuroHPC centers. There's now a longer list of those, but of the first 5, Barcelona's a supercomputing center in Spain, and CSC in Finland were 2 of the initial 5 group. So we have good links into those, and we're trying to explore and increase engagement with the high performance computing communities and initiatives, and better align our activities with the development in those areas. Don't have time to go into, but Gaia-X is also an important feature. So that's this sort of joint French-German government-led initiative to build or make available standard components for computing, in their case focused a lot on local government and smaller industry as well as larger industry. But what none of us want to do is reinvent wheels when we don't need to. So it's about aligning and making sure we share best practice, and indeed redeploy and make use of things made available through these other initiatives. So EOSC is one of our key ways of gluing these things together, EOSC being the European Open Science Cloud. And so we work closely through the projects listed here. We have a whole set of projects in ELIXIR which have elements of the compute platform involved, whether it's Euroscience Gateway, that's actually a Galaxy project, but there's a strong link there with compute in terms of aligning the Galaxy compute environments with those Global Alliance compute standards I mentioned. EOS Future project will come to an end this year, but it's been developing the marketplace further for users and the providers portal to EOSC. And you'll see the links there. So increasingly, what we're trying to do is deploy deploy services through ELIXIR, register them in this marketplace, and make sure that they're available to an EOSC-wide community. And we've listed under compute, but you'll also find the other platforms listing their services, priority areas through our 2022 ELIXIR EOS strategy document. And there's a focus group which meets monthly if you're more interested in that aspect in particular. Just contact Gavin or myself. So in a final forward look, we believe that over the last few years, we're at a point now where we can contribute to and build an ecosystem that supports reliable processing and analysis of sensitive data in particular, but that also covers environments for non-sensitive data. And that we expect to deliver services in support of that federated data management and analytics for life sciences. And you'll see a sort of more evolved set of tasks that we're planning under that. And I'll just briefly mention those now. So federated distribution authorization is the next big step in advanced service access control. So this is all building on the AAI work I've described previously. And elevation of trust, it's obviously all working under GDPR and related data protection regimes. And this means complex access control specifications, but higher privacy for users. And then it's about connecting the other tools using these technologies, and how to integrate those with the relevant infrastructure, but importantly, how to demonstrate provenance and reproducibility. and make sure we are fully aligned with the ELSI ethics and other frameworks, and of course cybersecurity management. So all of this needs audit trails and provenance, and that means there's a third A. Instead of referring to double AI, we increasingly will be referring to triple AI, and that the third A is accounting. We will not be able to deliver the kinds of services we're working towards using sensitive data without that audit trail and without that important element there. It's actually very important just for managing cross payments in Europe for non-sensitive data. So that third A is going to be a key part, the accounting, the audit in the new program. And then European regulation is tightening, and we need to adapt to that through a second task, which will be protected access to sensitive data for analysis. And that's about more evolved access rights management, ensuring the proper levels of assurance and granularity of access rights to support that European-wide interoperability. And then once you have that secure access in place, you still need to be processing and analyzing in a secure way where appropriate. And that covers discovery tools, trusted analytical environments, and then onto the publication. And the connections across compute, the way you can see that this fits into all of the areas. The second bullet really highlights the two key things that we're working towards. So we will need resource entitlement management systems. This has been led by the Finnish node, the REMS service, and that's really underpinning the new genomic data infrastructure project in many respects. And what we want to be able to do is connect that with the Federated European Genome Phenome Archive, and to be able to do this in a way that's joined up across our platforms and communities. And then finally, the multi-cloud infrastructure deployment with use cases, the more we need to outsource that peak performance requirement. Even large nodes, large infrastructures, large institutions, even the largest ones don't necessarily have enough power at times to meet the requirements for particular analysis. So it's really about shifting towards the cloud to make that possible. We've talked about how we've been exploring hybrid cloud and containerization and using community standards to do so. But we will be working towards bundling those, hardening those services, and making them actually usable and deployable in these federated hybrid use cases. And that's all about the microservices I've described and operationalizing it. So I'll skip over more of the detail of that here in the interest of time. You can see some of the core technologies involved. It's a common workflow language, as well as Nextflow, Galaxy, and so on. And I've mentioned already that we will be further developing what the providers need, what the administrators need, which is a software development kit to support this. And then I guess the piece which we cover in different parts of what we do in ELIXIR, but that we haven't brought together in one place, is this task 4, which is sustainability, accounting, and provenance to enable this federated analytics. And again, I've said most of the words here already. It's about the appropriate audit trails and so on, in order that we can make these use cases possible. So final summary is that we've made a significant contribution already to this federated analysis technology and the standards development. Data is going to be federated, and compute should be as well. So to sustain this, we need to see a way to establish a service where a researcher can execute their workflows in the compute environments near the data, and those services requiring full accounting and governance. So get involved this way. There are many different ways to get involved. Slack boards, mail lists, meetings. I won't list them all. Important thing is to take part, contact Gavin or myself, We have multiple events, event reports, and anyone with an interest in compute is very welcome, and we can happily point you to the relevant mail lists or boards to get more involved.